consumers want everything. And we believe that at Skycross, we have the IMET technology. That's clearly the next technology as things get smaller to solve what's we call the digital home or 4G going forward. And it's clearly essential to everything that rolls out in the future. Thank you. Thank you for your time.
Great. Thank you, Al, and thank you, Babak. Before we throw it open to the floor for questions, I've got a couple for both of you to speculate on. And if anybody from the audience wants to speculate on this next question, feel free to raise your hand. We've recently seen Nokia announce their netbook, which is going from being a phone manufacturer to being a computer manufacturer, if you will, and certainly addressing directly the question that this panel is about, is our device communicating or computing? Do you see other manufacturers potentially switching or adding different device types to their, without telling us anything proprietary from some of the discussions you've had, changing the types of devices that they're making because of the convergence of the technologies? Babak, would you want to take a crack at it first?
Well, I wouldn't speculate on who else will be working on this, on this, but just looking at the two announcements or rumors, if you will. One, the Nokia's netbook, and the other one, Apple's larger screen size device. They both point out that the focus is definitely going towards this convergent device. There was, in fact, an interview with the director of development at Nokia about the netbook, and she indicated that Nokia is moving towards 50% hardware, 50% software in terms of the internal capabilities. They do see that software is the power that can respond to the consumer's demands. It is interesting that now they're moving beyond the form factor of a phone, and they sort of are dabbling in an environment that they haven't been before, in a domain they haven't been before. But those moves are calculated. For example, Nokia did not go with their Symbian OS, which they made open source last year. They went with the Windows operating system. That is basically to cater to the working traveler, to the business person that feels more comfortable running their applications in the Windows operating system. They're at the same time are bundling lots of features in their device. For example, the device is supposed to be 1.25 kilograms, which is a competitive, if you will, size for a device that has a number of connectivity features, including the GPS. It does have the multimedia capabilities, and it's supposed to be also a reasonable business system. There's a lot less information available from the Apple's perhaps device. Everybody's waiting to see if the announcement coming up will talk about it. But again, rumors indicate some screen size somewhere 7 to 9 inches diagonal, and capabilities that, again, the idea here is, let's just end my comments, that we talked about convergent device. There is no device in the near future that will do everything for everybody. Okay, so it is a device that is targeting a particular sector of the consumers for their variety of needs. Look at the market today. We have, for example, the Garmin Nuvi phone, right? So it is a phone, but it is centered on location-based mindset. Okay, so your contacts are immediately located on the map. Your, it's a map-centric, location-centric device. It comes standard with the, with the turn-by-turn navigation, etc. iPhone, Some people have talked about it to be a iPod, that makes phone calls. So you have essentially the segmentation of the market based on the set of demands of the consumers. And now what this new set of products promise is simply casting the net a little bit wider. All right. So by a netbook, now you have the capability to capture more features than a narrower segment of the consumers.
Al, would you care to comment?
Yeah, I'll expand on Bob's comments there. Well, a lot of us may know or may not know. I mean, it's in the press on this, is that Nokia has done a very good job in Europe, and they've always struggled to do the same in the U.S. when it comes to the smartphones. Companies like RIM and Apple and Palm have done an outstanding job, awesome job, getting to deliver what the consumers want. And I think that where a lot of these handset manufacturers are coming now to is that when you look at the netbooks themselves, that's kind of like the hottest little product out there that's coming forward. There's money to be made. There's services to wrap around it. If you look at where these things are built, I mean, there's 3 manufacturers, number 1 manufacturers in the Far East, and they include Quanta, Compal, and Wistron. So you, as an OEM, can come up with your feature sets and go to the Far East and have built whatever you want. And a lot of these manufacturers do that. And I think what's going forward, I think you're going to see more companies offering technologies that can compete in the market and give the consumers what they want. Just to give an example on numbers, I mean, netbooks today are about 5 million. They're going to go to 60 million in the next 3 to 4 years. So it's a huge surge of uptake, and I think we're going to see more of that coming forward.
Okay. Next question for both of you. Before I open up, one more, and then we'll open it up to the audience. What do you see are the major impediments to take-up of 4G technologies, either WiMAX or LTE or some other 4G flavor? Is it cost? Is it technology? Is it radios? Is it antennas? Is it all of the above? What do you see?
Okay. I guess for anybody who's old enough to have gone through the 3G hoopla back in the 99, 98 time period, that cost has become a major concern. In terms of this was discussed actually briefly in the previous session. You do remember that the European operators had to shell out billions of euros purchasing spectrum for a technology that they had to wait a few years to actually get revenue from. The technology itself was expensive in terms of the cost of development. The physical layer was complicated. The core network was complicated. You had this very traditional hierarchical structure to your network, and that increased the deployment cost as well. A lot of those are in the back of everybody's mind. The cost, the complexity of the technology has been reduced significantly. At least the standard bodies, heard the message. The core network, the network's infrastructure for LTE is significantly simplified compared to its predecessor. The protocol stack, which used to be a nightmare in terms of the layer 3 RRC, has been significantly simplified. Even though, as you might have heard, there is no single standard for voice over LTE as we speak, but it is an entirely IP-based infrastructure. So what I see is the roles have been somewhat shifted. Europe and Asia typically have taken the lead role in adopting new technologies. U.S. sort of had a wait-and-see attitude. This time around, it appears that the U.S. operators are taking the aggressive approach. Verizon and ATE and a couple other operators have indicated the rollout plans for LTE. So I think the experience of the 3G has made operators somewhat more cautious to make sure that there is, if you remember the term killer app, which was supposed to come with the 3G and it never happened. They want to make sure that there is a revenue model for them to recoup their investments. But in terms of the handsets and the consumer devices, the bar is not as high as it was given the technology at the time for the 3G.
Yeah, just to expand on that, the carriers are going to have to figure out how they're going to make money with this, right? And there's a lot of technologies out there today. If you're in a building, you got Wi-Fi. You have WiMAX coming on, and with LTE and coming on very shortly. These are all going to play a role in the way the 4G comes forth going forward. Another huge issue is coexistence. How are all these technologies going to coexist in the marketplace? I can tell you now that Wi-Fi, like 802.11, working group worked very hard with the Bluetooth SIG on making sure that Wi-Fi is not a Bluetooth killer. Okay, making sure that they can coexist in the same frequency band. But it's not in the same frequency band, but it's adjacent bands. So as WiMAX and Wi-Fi get deployed, that will be a challenge as well. And certainly with LTE operating in the same band as WiMAX and adjacent to some of the Wi-Fi bands. So coexistence without causing any one technology to destructively fall apart, and certainly how our carrier is going to make money out of this will be the pivotal points going forward.
Great. Okay, audience. Gentleman over here, you had a question before?
I was just wondering, after your discussion on convergence, when does convergence not make sense? So if I look at the model like the auto industry, where you have a utility vehicle and you have a high MPG vehicle and you have a people carrier, it doesn't make sense to make one vehicle try to do everything, right? So at what point does this industry know where the limitations are in convergence? Where does it not make sense to converge?
Let me take a crack at that one. I believe we've sort of had the marketing strategy. I believe the summum bonum of the marketing strategies has been the segment of one, building the product for the individual. Now, and I think we're getting closer and closer to that with the software and hardware capabilities to allow me to choose which devices I want to travel with. I used to travel with 4. I now only travel with 2. It's getting better for me, and I'm probably a pretty difficult user. I do believe that the difference between the mobile traveler while traveling versus the mobile worker in multiple different fixed locations is a different segment, or are different segments. Then there are going to be consumer segments, various consumer segments, Generation X, Generation Y, Generation Z, and one I heard yesterday, Generation XX. Oh, no, that was the World Wrestling Federation. I'm sorry. But the segmentation, I think the products are going to evolve for the segments. And they'll converge where it makes sense and diverge where it makes sense. And I think the opportunities as the costs reduce for new players to play in smaller and smaller size segments will make a difference. My thoughts. Al, would you want to try?
Sure. Well, it's like any new technologies, right? You'll have first, second, and third generation. And one of the things that we're seeing like right now, at least from the antenna perspective, because we see everything, right? As I said, first thing, last thing that touches the radio and the airwaves. They want everything in kitchen sink, everything under the hood, right? So they're planning for adding all this technology. The jury's out, right? So you have Wi-Fi today, you have cellular today, various flavors of cellular depending on where you're at in the world. Clearly, everyone supports a world band, but what's going to happen going forward? Are you going to support WiMAX, LTE? Is one going to win over the other? That's yet to be seen. So I think everyone's planning for everything, and then what's going to actually fall out is whatever the carriers decide, where you're going to be using this, either in North America or the rest of the world, will determine what what makes sense and not converging. Will you come to a limit on convergence? Yes, on the semiconductor side you will. I don't foresee in the near future where you're going to have a single chip that does everything, at least from the radio perspective. Maybe in the baseband in Mac, as Babbitt pointed out, but from the radio perspective, the physics of design just don't allow that. It's impossible. If anyone has an idea, I'd like to go offline and talk to them because we can become instant millionaires here. All right, so it does not allow you to do that with today's technology.
You mean it's not the magic of software, as Mr. Gates would say?
Not yet, not yet. So on the semiconductor side, they're not going to converge into a chip. So you're going to have various challenges to meet there. But on the usage side, that's all going to come down to us in the room, what we want.
Babak?
There are three factors at play in here. One, as Al definitely mentioned, the physics. All of the newer technologies require multiple antennas, or at least leave it as optional features, which simply means that if you want to have the coverage, you want to have the capabilities, you will go with the multiple antenna. So, that automatically puts a limiting factor on the size and the number of technologies that you want to support simultaneously. The other factor is, standards have always had a tendency of designing the standards for a particular top data rate, which may not necessarily make sense given a given time. When the UMTS defined the 2 megabit per second category for the downlink, there was really no, besides the fact that there were, technological issues, you need to, give an entire cell to one single user, there was no really use case for somebody using 2 megabits per second. That factor is already around, and I'm seeing it. Since LTE is defining the category 3 to be 100 megabits per second, you notice a lot of operators are already gearing up for category 3 requirements, okay? Do we as users, envision a situation where we're going to utilize 100 megabits per second over the air? Again, the scale that it would make sense, business-wise for the operators. So sort of playing catch-up with, what the top bit rate of a standard is has always been a factor that needs to be taken into account. If I, as a operator, as an OEM, define a particular data rate that is not necessarily the top rate, it allows me to actually manage my convergence better. Designing a 100 megabit per second LTE handset is going to pretty much use up all of your power budget. The third factor is, I'm quoting here Michael Gartenberg, who's the vice president at Juniper Research. And he says, just because companies can converge technologies into one device doesn't mean they should do it. You notice you heard I alluded to the camera integration into the handsets during my presentation. We're sort of accepting the cameras integrated into our mobile phones simply because they pretty much are given away for free. But do we as consumers prefer the grainy pictures that your 1 or 2 megapixel camera in your cell phone offers you, or an 8 megapixel photo that a standalone camera gives you? So, is there a use case for a camera being converged? I'm using an extreme example here because we sort of can touch it on a daily basis. So just because we can converge it doesn't mean that it should happen. So going back to David's comments, I would say that it has to be carefully contemplated what sector of the consumers we are targeting, and then you could put the bells and whistles for that target audience into a device. Again, I stand by a statement that a one-size-fits-all Swiss Army knife, digital version of a Swiss Army knife is not feasible, not today, not in a long time.
Okay. Carl, you had one?
I have one, but I'll do it. It was interesting with the slides, and I thank you guys for them. I'm a very visual person, so I need them. One thing that was I gathered from yours, David, was the ubiquitous nature of Wi-Fi in this world. While we're all fighting about the standards, Wi-Fi has emerged as kind of of the gentle blue. So the question I have is there a case to be made that federation in this world can happen via Wi-Fi rather than basically going back into the existing standards? So I wanted to hear your guys' thoughts about that.
My initial reaction is, yeah, I mean, but why should we do something smart? We never seem to. It wasn't designed that way from the ground up, and given that it wasn't designed that way, it's almost impossible for it to happen. My thinking, but maybe we'll be like a blind hog and find something that we want to eat by accident. I doubt it, though. Comments?
I would just comment that since 802.11 was designed not with mobility, that it's a major handicap. And, to its credit, it was never designed to be a, wide area or metropolitan area network standard. We sort of are shoving it into that domain, that wasn't intended for. It will be there. It needs to be there. I see it being present in handsets for quite some time. But that was the reason that the other flavors of 802.11 came into the picture, or 802.16 rather, to handle the mobility issue. Right now, what we have without the cellular technologies is a nomadic system, as you heard it. You're not continuously mobile. You go from one location, you get disconnected, you're attached somewhere else that the coverage is there.
Yeah, I would also add that 802.11 Wi-Fi is probably the most successful standard. Having been part of this for most of my career on the face of the earth, when it comes to, if anybody's ever gone to an 802.11 meeting and you got some of the brightest people in the world sitting in that particular session. I'll also make a note that a lot of the other spin-offs, your Bluetooth, your WPAN activities have all spun out from .11. Not to mention 802.16. Everything that you see today happening in the world is from the work we did back in the early 90s. And I've been involved when that group was only 60 people. And there's a lot of good that's coming out of it. Where do we go from here? The groups are already working with 3GPP. They're working on addressing LTE with the IMT Advanced Group in IEEE. So I think you're going to see a lot more good coming out of the standards work. And not only because of the standards, it's the companies that are involved. You have some of the world-class leading semiconductor companies that are there. You have some of the other suppliers. You have the carriers. You have the handset manufacturers. You have Apple. You have RIM. You have Clearwire. You name it. They're all in these groups. They all come 6 times a year, and then they do a lot of work behind the scenes. So I would argue that you're going to see more good come out of this group, and also address world-class mobility going forward. So,
great. One last one from the audience. Well, in the back.
That's true. By the way, that's Fanny Malarski. She's accredited for a lot of her work into testability on the side of things that you'll hear later. But MIMO and OFDM. OFDM all started when this ubiquitous across all wireless communications back when 802.11a was formed. Everybody was focusing on B products, and then 802.11a was adopted, and OFDM was written to that standard. And then they found out that became the technology going forward, the modulation scheme going forward for WiMAX and a lot of the cellular technology. So there's another good example of what's come good out of this particular standardization process. So yes, it's painful. Yes, it takes a long time, but good things don't come short. So it takes a while to get there.
I'm going to quickly argue that there's been one other that's been more successful, and it's called Ethernet.
But we jettisoned off that.
Yes, I agree. Rebecca, to comment on that?
Oh, no.
Okay, great. The panelists can hang around for a few minutes if you want. I thank you. Let me thank our panelists for a great session, and we look forward to continuing this in the future with somebody who can talk effectively about batteries and power.
All right, thank you.